Lesson 5.4, Factoring Polynomials. We're going to look at, review some types of factoring that you've learned so far, and we're also going to look at some new types of factoring. First of all, let's just review what factoring means, or factoring polynomials means, and that is to write an expression with parentheses. Okay? Some things that we're going to look at. Let's highlight some things here, and we're going to look at factoring the greatest common factor out of an expression or polynomial. We are going to review factoring a difference of two squares, and we are also going to review a couple new topics: factoring sum of two cubes and difference of two cubes. Okay. And there's a help sheet we've developed that you can use. You just need to know how to use these little techniques. Okay, and we're also going to look at a couple examples of factoring by grouping here. Okay, so factoring greatest common factor is what we're going to look at first, and this should always be your first step in every type of factoring problem. Okay, if they tell you to factor, and they're not going to say factor out a greatest common factor all the time, or factor by grouping, or factor this difference of two squares, or whatever, they're just going to say factor. So much of factoring is recognition. You need to recognize what you need to do. First step in every factoring problem is to always check to see if you can factor out a greatest common factor first. That is, factor the greatest common factor out in front of parentheses and figure out what's left. This is kind of the opposite of the distributive property that you've learned. Okay, so here again they're just telling me to factor. They don't necessarily say factor a greatest common factor. So if we look at this, we've got a trinomial right there. Okay, we've got a trinomial. We have 10a cubed b squared plus 15a squared b minus 5ab cubed. Okay, we need to, if we can, factor out a common factor. That means put the greatest common factor out in front of parentheses. So if I look at the 10, the 15, and the minus 5, I can take out a 5. So I'm going to put that out in front of parentheses. Okay, every term has an a on it. I have a to the third, a to the second, a to the first. You take the smallest exponent on variables that are in all the terms that you're factoring out. So I'm going to take a to the first. And you have b squared, b, and b to the third. So I'm also going to factor out a b to the first. Okay, then you need to figure out what's left. If you start with three terms and you factor out a greatest common factor, you will always have three terms left inside. If you started with 2, you will always have 2 left inside. So in this case, we're starting with 3. Think opposite the distributive property. So 5 times what will give me 10? Well, that's got to be a 2. So we're going to put a 2 in here. And then I factored out an a. I have a cubed right here. So this has to be a squared. I factored out a b. I had b squared right here. So I have to have a b on that first term. Okay, we're factoring out a positive 5ab, so signs are going to stay the same. So now I look to my next term. 5 times what is 15? Well, that's got to be 3. So let me use a different color here, but I'm going to have a 3 here. I factored out an a. I had a squared. So a times a would give me the a squared. I factored out a b, and I only had a b, so there will be no b on the middle term inside parentheses here. So I just get 3a for my second term. Okay, then we go to the last term. Okay, we factored out a positive, so this is going to stay, the signs are going to stay the same. Now, I factored out a 5, I only had a 5, so I have a 1 here. Again, if you want to write it there, you can. I'll write it there this time. I took out a. I only had an a to the first, so I won't have an a on this term. I took out a b, so I will have b squared left there. Now, so your answer is 5ab multiplied by 2a squared b plus 3a minus b squared. And like I said, if you want to keep the minus 1 in front of the b squared, you can, but that would be your answer to that particular problem. Okay, now we're going to look at factoring by grouping. which usually involves 4 terms. So if you want to factor by grouping, you want to group a couple terms together that you can take something out of, and then group the other 2 terms together that you can take something out of. Okay? Because if you notice, I have these 4 terms. There is no common factor in all 4 terms. So we want to check, can we factor by grouping? And this is something new. You've not done this before. So what I'm going to do is I'm going to rewrite this as x cubed plus 5x squared, and I'm going to group those 2 terms together. Okay, now I want you to notice right here where we have the minus sign. Okay, so I suggest writing that as plus and then grouping negative 2x minus 10 together. Okay, and that only occurs, or you only have to do that if there's a negative sign, again, on this 2x right here. Okay, or that third term there. Okay, so now, if you look at this right here, I want to factor out a common factor. Well, I can take out x squared from those 2 terms, and I'm left with x plus 5. So all we're doing is factoring the greatest common factor out of those 2 terms. Now I'm going to go over to this right here, and I'm also going to look at what can I take out of these 2 terms. You can't take a variable out because there is no variable on the 10, but I can take out a negative 2. So I'm going to write it as plus negative 2, and I'm going to be left with, if I take the negative 2 out, I'm left with x. Factoring out a negative will change this sign right here to plus, and then 2 times what is equal to 10? That's got to be 5. Now I want you to notice this right here. Here's what I want you to notice. Okay, let's use yellow here. I want you to notice what's common right here and right here. Your binomial factor, or 2-term factor, of x plus 5. So what we're going to do now is take that out of each, kind of think of this as being in half. We're going to take that out of the left half, this over here, and we're going to take it out of this side and see what's left. So I'm going to factor out my common binomial factor of x plus 5. There's a times in between, and now what you're left with is really this right here. You are left with this and this. So everything that is outside of parentheses. So I'm left with x squared plus negative 2. Now let's rewrite that. So I really have these 2 binomials, x plus 5 times x squared, and I'm going to write this as minus 2. Okay, and that is your final answer, a binomial times a binomial, which is usually what you have when you factor by grouping. Now, to check this, and I'm not going to go through this whole process, but if you want, you could stop it and check it. If you FOILed this together, okay, if I FOILed these 2 binomials together, you would get the original x cubed plus 5x squared minus 2x minus 10. Okay, and you can double check that. All right, so now I'm going to go to the next example right here. And I'm going to come down. I'm going to need a little more room, so I'm actually going to write this down a little bit further here. So here's what we had. We had a cubed so I have a cubed minus 4a squared plus 3a minus 12. Now sometimes you might have to rearrange the order of the terms to group like the first 2 together so something can factor out. But I notice right here, if I group these 2 together, okay, now this is a plus sign this time in front of the 3a, so I don't have to really write, you know, plus a negative, and I group those 2 together. Now I can take out an a squared sorry about that, I bumped my screen there. But I can take out a squared from these first 2 terms, and I'm left with a minus 4. Okay, if I factor a squared out of these 2 terms, Over here I'm going to take out a 3, and I'm left with a minus 4. So once again, notice your common binomial factor right there. So now, when you write it, it will always be two binomials. It's a minus 4. And always what goes in the second binomial is basically everything outside of your parentheses there of the two a minus 4s will have a squared plus 3. And it's multiplication in the middle, not plus. And if you foiled that together, you can check and see if you got the original problem. But that would be your answer to the second one. Factoring by grouping. Okay, so now we're going to go down a little further. Factor each polynomial. Okay, now we've got some with 2 terms, some with 3 terms. Your first check on everyone is, can you factor out a greatest common factor? That's the first question on every factoring, whether there's 2 terms or 3 terms or 4 terms, whatever. Okay, notice on this first one, this 3y squared minus 2y minus 5, I cannot factor out a y. I can't take out the greatest common factor of 3, 2, and 5 is 1. So this gets into what we call trial and error factoring. Okay? In other words, we're going to try and factor this into 2 binomials, okay, to get 3y squared. The only possibility would be 3y times y. So what I'm going to do is I'm going to put 3y in one of these, y in the other. Okay? Then I go to what we call the c value, which is negative 5. Okay? And I list pairs of factors of negative 5. Well, I have 1 and negative 5. Okay? To get a negative, pairs of factors meaning the product when I look at them. Or I have negative 1 and positive 5. And all you need to do, this is why it's called, or why I call it trial and error, is try them. So we're going to try plus 1 minus 5. And here's the test. You need to see if, when you do those and these, outside and inside, like you were foiling, if I get my y term on the original trinomial. Okay? Well, I get minus 15y when I do my outsides here, plus 1y, which is negative 14y. So that doesn't work. Okay? So what we need to do, and I'm just going to click on the undo button, is that didn't work. Okay? So we tried that. So now you switch them. So here's what I'm going to do. I am going to try the minus 5 over on this side and the plus 1 here. Notice now when I do my outside and inside, I get 3y for the outside, negative 5y for my inside if I was foiling them. When I combine negative 5y and 3y, I get negative 2y. So this would be how that trinomial factors into the binomial 3y minus 5 multiplied by y plus 1. Okay? So now we go over to this one right here. And we have 5mp squared minus 45m, 2 terms. But I notice that I can take out a greatest common factor. That's always the question you need to ask yourself. Well, I can take 5, but I can also take out an m. And I'm left with p squared, if I take 5m out of the first term, minus 9. Okay? Now, many students always assume they're done factoring as soon as they factor out the greatest common factor. That's not always the case. You must check to see if you can factor what's left. And I have p squared minus 9. That is called a difference of 2 squares. And a difference of 2 squares can be factored into 2 binomials. You carry down the 5m, has to be part of your answer. And then what you square to get p squared goes in the first spot in each one, which is p. This is also a perfect square. I square 3 to get that. So those go in the second spots. 1 is a plus and 1 is a minus. So it's 5m times p plus 3, p minus 3. Okay? And that would be your answer to that particular problem.